in recursive programs, we have seen that if we have a recurrence relation, then we can easily convert it to a recursive function. And also we have seen how a recursive function works, having different environments for each time the function is called. Here I will do one more recursive function and also again show you how the recursive programs work using that same concept of different environments. Now see, the recursive program that I will start with, let it be the recursive program for say sum of digits of a number, say sum of digits of a number. Now you know that if I have to do it using a for loop, a lot of logic is required. However, if we really think of recursion, then say suppose the number is 374, I can say sum of digits of 374 is, see, sum of digits, if I call it a function, say SOD, stands for sum of digits. Then how is sum of digits of 374 calculated? You may say it is the sum of digits of 37. Please understand, 37, 374, just the first two digits I take, 37 plus 4 added to it. See, very simple. You add 4 with 37 sum of digits, you get the sum of digits of 374. Sum of digits of 37 added to 4 is SOD of is sum of digits of 374. Like if I say sum of digits of, say, a big number 492351334, big number, what is it? It is sum of digits of, take the first few, 4923513, 4923513, sum of digits of this number, then 4 added to it. Is not it so? So this is how sum of digits is computed. Now if I go for general formula, then the sum of digits of a number n, what is it? It is basically sum of digits of n divided by 10. If n is an integer, n divided by 10 will just get rid of the last digit. So see, if I think of 374, just the example above it, check out 374 divided by 10 is 37. So SOD of n is equal to SOD of n by 10 plus the last digit. How do you get the last digit? n percent 10, the last digit you get like this. Is not it so? 374, SOD of 374 is SOD of 37. That is 374 divided by 10 is 37. But 374 percent 10 is 4. So n percent 10. Like this, you check out. 49235134 divided by 10 is 4923513. So SOD of n by 10 plus the last digit 4 is n percent 10. So I think you understand this. Is not this quite simple? So this is how sum of digits of a number can be computed. But then again, you will have to think that there has to be an end point. Then what? SOD of n, see this, is equal to n itself if n is less than 10. See, if n is less than 10, n is 0, 1, 2, 3, 4, 5, 6, 7, 8 or 9. So the sum of digits of 9 is 9 itself, sum of digits of 8 is 8 itself, sum of digits of 7 is 7 itself. For any number n less than 10, SOD of n is equal to n. This is if, this part is then if n is greater than equal to 10. Is not it so? If it is greater than equal to 10, use this logic. But if n is less than 10, then this logic. So how to write this program very easily? Very simple. The sum of digits should return an integer. So int sum of digits. Is not it so? So this is the function name. I will receive an integer n. Then definitely I will have to check one very simple thing. If n is less than 10, then the sum of digits is n itself. See, if n is less than 10, then SOD n is n. So what should I return? I should return n. My job is to return the value. So return n. If n is less than 10, return n. Else, what do you need to do? You need to return what? Sum of digits. See, SOD n by 10. So sum of digits within bracket n by 10 plus the last digit n percent 10. Is not it so? So this is what you need to return. So else return this sum of digits n by 10 plus n percent 10. If needed, you can give a bracket like this to make the things easily understandable. Else return sum of digits n by 10 plus n percent 10. You can avoid the bracket also. So here I can only call this function and get my job done. So sum of digits, if I call it say with 5, 6, 3, 4, 2, a big number, but it's a long int, then you are calling for int, you may give a big number over here. So you can give for a long int, it may receive a long int, no problems with that. However, a return will be integer because sum will be always smaller than the big number. 5, 6, 3, 4, 2, its sum is 5 plus 6, 11 plus 3, 14 plus 4, 18 plus 2, 20 only. But 5, 6, 3, 4, 2 is a big number. So sum of digits 5, 6, 3, 4, 2 you can call, and you can directly print it, or you may receive it somewhere and then print it, whatever. I am directly printing it. Printf %d because it is an integer. And call sum of digits 5, 6, 3, 4, 2 maybe you call for. If you run this program, it should run fine. You may check out only if you comment out this extra portions you have written for explanation. So commenting out. Let me run this program. Okay. Yeah, I think this is fine. Enter. So 20. I had called for. I had sent it 5, 6, 3, 4, 2. Definitely it returns 20. It answers 20. You go for only 5, 6, 3, 4. See. It is 18. The 2 is missing. You may go for 1, 2, 6, 4, 7, 9. 6. 1, 2, 4, 7, 9, 6. Let's see what it does. It says 29. 1 and 2, 3. 3 plus 4, 7. 7 and 7, 14. 14, 9, 23. And 6 is 29. So it works fine. Now if you have to check how it works once more, though I have done it, but still once more, checking it once more. I save it and I quit from here and show you in that same Word file how it works. Once more explanation. So see how the program I had written, int sum of digits. Very quickly I will show how it works. Sum of digits followed by you have received a long int n. Long int n. You have received this. Now you will write the program. If n is less than 10, I return n. Else I return the same sum of digits I call for, pass to it n by 10 and add with that same thing n percent 10. Let me put this within a bracket. N percent 10 added to it. So this is what you have done. This is the program. I close it and let me remove all this auto capitalization of else, if. I don't need this. This int has to be in small letters. So int sum of digits long int 10, if n less than 10 return n, else return sum of digits n by 10 plus n percent 10. How this program works. See how it works. First and foremost, you need main. So let me insert this shape, a circle, and this is your main. Say this is main. So I insert a text over here. This is your main. Okay, so this is the main function. So the main function calls what? It calls for the function of this sum of digits. Now this sum of digits will be called for. So let me copy and paste this. This is the sum of digits which the main function will be calling for. So in this sum of digits function, what is the n that is being passed to? Say the n passed to is 3273. So you need the sum of 3273 digits of 3273 to be added together. This is a small n maybe. So n equal to 3273. Main has called this. Let me explain, show you that main has called it by an arrow. So main has called this with n equal to 3273. So once n is equal to 3273, main has called it with n's value equal to 3273. So within this sum of digits, the function starts working now. See how it works over here. It has received a value of n equal to 3273. I can say this is an environment where the value of n at the moment is 3273. N is not less than 10. So else, return not possible until the sum of digits is called for, and the plus is also not possible until the sum of digits n by 10 is called for. Then only plus will be possible. So this plus is possible only after the call of sum of digits n by 10. So a new environment being called for, to which 3273 divided by 10, that is 327, is being passed, and this 327 will be received in this new environment as the new value of n. So I can say I copy this and I paste this. So 3273 not been passed. What is passed to this new environment is 327, because n by 10 passed. If n by 10 passed in the new environment of sum of digits, the new integer n that is received is having a value of 327. So I again insert that arrow. Right, so n is 327. Now once n is equal to 327 in this new environment, n's value is 327, does not reflect on the previous environment, because you remember that one function local variable has got no role to play on another function's local variable. Here the functions are same but the instances are different. The sum of digits first time was called by main. This sum of digits has been called by sum of digits itself. It's a new environment. So the n over here is 327. So again, if n less than 10 is false, so the else part, return not possible until addition is done, addition not possible until this calling is done. So again what will be done is the calling with sum of digits n by 10. That is a new environment will be created. Let me copy and paste this. So this is the new environment where the value of n is not 327 but 32. So this 32 is the new instance. So not in this new instance of sum of digits has been created with n equal to 32. So this n is 32. If n less than 10 is false, so the else part return is not possible until addition is done, addition not possible until sum of digits is recalled again. If recalled, it will call with n by 10. N is 32, n by 10 is 3. So this n that is received is 3 over here. So the sum of digits has been called with n equal to 3. So let me again paste. This is the new instance where n is not 32 but n is 3. You understand this? N is 3. So this new instance is created. N's value 3 does not have an effect on this n's value 32 because they are all separate instances of the same function sum of digits. Now n is 3. If n less than 10, true, return n will be executed. The if part, return n will be executed. Return n means what? 3 will be returned. So can I say that now what will be returned is 3? It will return, but what will it return now? It will return 3. So let me insert a text box and write 3 is being returned over here. Let it make it small. Let me make this size small also so that it fits. It does not take too much of space. Okay, so this is 3 that has been passed from the previous instance to this instance. So see what is happening as a result. I will just paste it over here. So this 3 has been passed from this instance to this instance. So over here 3 has been passed. But where in this instance? You can say this instance is dead now. It has been returned, so this instance is dead. This n is killed. This n is killed. So this 3 has been returned to over here. In this instance, the value of n is not 3, but 32. I am present in this instance which is active now. All these instances are living and inactive. This is the active and living instance where 3 has been returned, but value of n is 32. Now return means control is present where? Control is present exactly in the point from where it was called for. It was called from here. So the control is present over here where 3 has been passed. So it calls for 3 plus n% 10. N is 32. What is n% 10? N% 2 is 2. So it means 3 plus 2. Please understand, 3 is passed over here. Here 3 is present. N is 32. So n% 10 is 2. So 3 plus 2 is 5. So what is being executed? Return 3 plus 2. That is return 5. So what it does is it will return 5. Let me copy this and paste. Okay, there is some problem in pasting maybe. Anyway, I will just separately copy and paste. So here what is being returned? See, 3 was returned over here. 3 plus 32% 10 is 2. So 3 plus 2 5. It is saying return 5. So it is returning to this instance with a value of 5. Let me copy and paste this again. So now what is being returned, check over here, is 3 plus 2, 5. So 5 is where? This instance is dead now, this instance is dead now. This is the active living instance. These are living and inactive. So now 5 has been passed over here. So what is present over here is 5. 5 has been passed exactly, control has been passed exactly to the point from where it was called for. It was called from here. So here 5 is present. But n over here is 327. So remember, n in this instance is 327, not 32, because this instance is dead. In this instance, n is 327. So n% 10 is 7. 327% 10 is 7. And here 5 has been returned. So 5 plus 7 makes it 12. So what is being executed is return 12. Remember, so this is returning 12. So I copy this and I paste this and I show that return is again happening. So what is being returned is 12. I copy and paste this again. I trick it over here. This is just 12. I increase this so that 12 can fit. So this is 12 now. 12 has been returned. This instance is dead. This instance is dead previously. This is dead previously. This instance is now dead. This is the active instance, living and active, and this is waiting. This is living and inactive, waiting for its invocation again. So this 12 is now returned. Where is it returned? It is returned here. Here 12 is present. Please understand. Here 12 is present, but now n's value is 3273. This n now in this instance is 3273. 3273% 10 is 3. This 3. 3273% 10 is 3. So 12 returned over here, 3 present over here. 12 plus 3 makes it how much? 12 plus 3 makes it 15. So it is executing what? Return 15. So here main to main 15 will be returned. I just show that with the diagram. Here now to main something is being returned. A value is being returned. What is that value that is being returned? 15 is being returned. So 15 is being returned to main. Remember. So the sum, that main gets the answer as 15. What did main pass to it? It passed 3273. 3 plus 2 is 5. 5 plus 7 is 12. 12 plus 3 is 15. So it is returning 15. This is how the program works. But remember, when you had written this program, you did not think of all these invocation of different instances, different values of n. You have just copied from the recurrence relation. If we go back to C, if I now minimize this and go back to C, you will find that you had written this program only by looking at the recurrence relation. So C is opening, let us wait. Yeah. So you see this. In this recurrence relation you had formulated the recurrence relation, you just copied the program from the recurrence relation, nothing else. So you have understood it once more. If you were given the job of counting of digits, please see this, I am now changing the program, another program, count of digits, COD, count of digits. What is the count of digit of n? How can you write it in the form of a recurrence relation? See once more, if it is count of digits of 374 with the same example, is not it the count of digits of 37, that is 374 divided by 10 is 37, plus the last digit 4 is accounted for, so one digit over here. So 1, this is one digit, and then count the number of digits in 37. Is not it so? I explain with another example. Count of digits of, say, with this number 4, 9, 2, 3, 5, 1, 3, 4. See, the last 4 is one digit, so one digit over there. And then the rest of the digits is present in the rest of the digits of 4, 9, 2, 3, 5, 1, 3. If you count the number of digits in this 4, 9, 2, 3, 5, 1, 3, you get the count plus 1. But you have to end somewhere. So the same logic, count of digits of n. Let me start with n. So count of digits of n. How much is it? It is count of digits of n by 10, small n. Count of digits of n by 10 plus 1. So what is the end point? The end point is count of digits of n, small n, is 1 if n is less than 10. If n is less than 10, that is 0 to 9, it is one digit, so count of digits of n is 1 if n is less than 10. However, if n is greater than equal to 10, so over here you can write, if n is greater than equal to 10, then only count of digits of n is count of digit n by 10 plus 1. So let me write this program. This sum of digits to be changed to count of digits. Then I will copy from the recurrence relation. See, the recurrence relation need to return an integer. It is either 1 or this value made of. So count of digit, let us receive log in 10. If n by n is less than 10, then return what? If n is less than 10, then return not n but 1. If n is less than 10, then you return 1. Else return count of digits, the same function being called for. Count of digits n by 10 plus not n% 10 but 1. See this. Count of digits n by 10 plus 1 over here. So I've done exactly that. Return count of digits n by 10 plus 1. So instead of calling for sum of digits, I can call for count of digits. So easy. Writing of programs have become so easy now with recursion. However, when you write the program, you really don't understand that so much environment calling and values changing, those things are happening inside. You are just writing in it using simple recurrence relation formula, and this will work fine. See, 1, 2, 4, 7, 9, 6. How many digits are there? 6 digits are there. Call it and see. See, 6 is there. It will work fine. You add one more, 7 should be there. See, 7. Is not it so? So this works fine. You can again draw the environment for this and see how it works. We'll come back with one more recursion program after this little break. Thank you so much.